Hey guys, hopefully everybody's doing well. This may be Friday, this may be Monday. I'm not sure when you're listening to me. But either way, I hope you have a pretty good idea now about the difference between a theory and a law. Alright? And remember, the theory is trying to explain what's going on, what's happening, the why part of it. And so, now we're going to be more specific to this astronomy stuff, and we are going to look at evidence that supports the Big Bang Theory. This is the last thing you do in this class. Okay, it's a couple days worth, but we look at two major lines of evidence. I'm going to talk real quick about three, but we're only going to focus real hard on two of them. And so the first thing we probably should do is actually define this Big Bang Theory. I oversimplify things sometimes. I just say everything was once together and went boom, but it's a little fancier than that. So, Big Bang Theory, it's not the only one out there that scientists try to use to explain the origin of the universe. This is just the most accepted. We've already talked about the oscillating universe idea. There's one called a steady state. This one has the most evidence behind it. Remember, it could be wrong. Maybe it's not right. Maybe we're gonna discover something, because goodness knows technology is advancing. Maybe we're gonna discover something that totally disproves this. But with the evidence we have right now, we think we are right. Okay? So the idea is that the universe originated billions of years ago. I'm going to start with that. And it's not my place, my job, my anything to talk about your belief system, but many religions would disagree with that right there, the billion part. Science says, based on formation of elements and things like that we'll talk about, scientists think it was billions of years ago, but that does not always align with people's personal religious beliefs. All right, so again, you can think whatever you want to think. It's like Planet Fitness here, man. Judgment-free zone. Okay, but science thinks it was billions of years ago, and the way they talk about it, it was in an explosion. And that explosion was from a single point. So just a little single dot. So a single point of almost infinite energy. All right, so there was just all of this energy was in this just tiny, tiny, ridiculous amount of space. Like I said before, almost like the tip of a needle or a pin. And it couldn't be contained there. It couldn't hang out. You can't compress it into that spot. And so that's when I talk about the boom part. There's technically not even sound in space, so it would not have went boom. But there would have been this explosion. Now, where my head struggles, because I think too much, probably, and anything I've read or looked at from the science perspective is there is no explanation to where that energy came from. And the people have ideas, but there is no evidence. Nobody saw where that energy came from. So that's always one of my big questions. And it doesn't matter what my belief system is at all, but based purely on the science can't explain where did that almost infinite energy come from. When I was listening to Neil deGrasse Tyson has a book called it's like Armchair Physics, something like that. I can't even remember the name of it right now, but even he says it was just there. He's a pretty smart dude, and he can explain everything up until from that boom till now, but he skims just the energy was just there. Well, how did it get there? All right, so that's one of those big questions. All right, evidence supports this part. All right, there's more than three pieces of evidence. We're just gonna I'm gonna talk about three. We're really gonna look in depth at two. So I'm gonna say evidence. Oh boy, I hear Earl again. Hi, Earl. So evidence of the Big Bang Theory. So BBT, Big Bang Theory. are you doing? Here. Any of you guys want to see this creature of mine? You see if I actually get him on here because I can't flip. Say hi, Earl. Hopefully I've got him in, or you guys are going to be very irritated with me. All right. So, evidence of this Big Bang Theory. First one. Cosmic background radiation. We didn't know this existed for a long, long time. But thinking about, even thinking just like a bonfire, man. It's bonfire season now. We're almost at camping season. All these great things are happening. And when you've got a flame, you've got like these embers around it. You get this glow. There's all kinds of different types of radiations within a good hot bonfire. Well, imagine an explosion of almost infinite energy. You're getting all kinds of crazy wavelengths that are generated. And so when that thing went boom, again, boom is a bad way of saying it, but when it exploded, we got anything from radio waves to gamma waves. And as it's cooling over, you see, cooling down, you see this stuff. This is leftover energy. And it actually does glow in the microwave range. So microwave range from our light unit, we better know what this is. Remember, from radio to gamma? So microwave is pretty long wavelength. Radio is a little bit longer, but it's pretty long wavelength, and we can use special satellites to gather this, and it actually glows in these satellites. So it's like leftover. It's like when the bonfire's cooling down, if we want to think of it that way. Oh my gosh, it's a zoo today. Lily Ann! Shh, stop it. All right. So the cosmic background radiation is the first one. Apparently somebody's walking by. This is going really well for me. Next piece of evidence, that's all we really say about this one, is the Big Bang Theory does offer an explanation. So it explains the creation of stars and elements. So maybe it's not right, but it does explain how we have the elements that even we are made out of. We have a ton of carbon in our bodies. Where does that come from? I'm going to show you here real quick. I got to believe everybody knows what nuclear fusion is from middle school, right? That's what stars are doing within them when they're in the main sequence, which is where they spend most of their lives. They're taking a hydrogen, which only has one proton. It's a simple little atom. They put it under pressure there within the core of the star, or the inner part of the star, and they generate helium. Helium has 2 protons. Those combine. In the process, it gives off light and thermal energy. That's why we are here. Okay, that's why we are around our sun, because of this process. The sun doesn't care about us. Hate to bust that, all right? The sun could care less if we're here. But as a byproduct of it doing this, it gives off some visible light, gives off some thermal energy. Here we are. But stars, as they go through their cycles, they can take helium, because once they run out of hydrogen, they got to burn something else. They can add 2 heliums together, and they make carbon. Carbon has 4 protons. They can put carbon together, make other elements, and we're going to get into that later, so I don't want to go any more specific than that, but this makes sense. Okay, these stars formed, you had this display of matter, some of it coalesced, right? Gravity grabs it, they start to come in together almost like a snowball, which is a really stupid analogy considering we're talking about something so hot, but it packs it. And then, okay, the first thing that happens, we fuse hydrogen, we got helium. As these stars heat up more, okay, we ran out of helium, crap. Well, now it's just going to start to collapse in on itself, and now all of a sudden it's going to fuse the helium. Now we've got carbon. Hey, DNA, okay, our instructions, we need carbon. We need nitrogen. We'll show you in the next class period, where does nitrogen come from? So this supports that. Maybe there's something else that will support that, and we'll find out that that is wrong. Who knows, all right? But that does work, and we'll look at this in a different class period. The third one, you already know this. We talked about in the light unit. We talked about a red shift. Remember Roy G. Biv. Red was a longer wavelength. Violet was a shorter wavelength. Doppler effect. Remember? That thing. Okay, that should ring a bell. Well, as things get closer to us, their pitch goes up. We don't care about loudness. We don't care about brightness too much right now with stars. We're looking at the wavelengths here. All right, so if a star was getting closer to us, if stars within the Andromeda galaxy, which is the closest one to our Milky Way, if we start to see what is called a shift towards the violet end of spectral lines. I know you don't know what that is yet. You just got to bear with me till you get to this gizmo so you can see what I'm talking about. But the stars are moving away from us. I'm not talking about our sun. That's in our solar system. I'm talking about the gazillion other stars out there. Okay, we're getting away from every other thing. And so what that does is it creates a shift. Just write down spectral lines for now. I know you don't know what I'm talking about. But it's really just like a marker that measures this wavelength of light. And it creates a shift in the spectral lines toward the longer wavelength, which is red. If stars in the Andromeda galaxy were coming towards us, we'd see the spectral lines shift here. But instead, all the stars in the universe are shifting this way, which means they have to be traveling away from us. Okay, they're getting farther away. It's the neuron part. Okay, that's how we know they're going away, the tail end of that. And so what we're going to be looking at is Hubble's law. So when we get to this gizmo intro here in a little bit, Hubble's law is the math that actually explains this piece of evidence of the Big Bang Theory. Remember, yesterday we said a lot of times the best theories are mathematically supported. Okay, we can't be subjective. We've got to be objective. All right, so 3 pieces of evidence that support it, and not saying it's right, okay, but this is what we look at right now in terms of why scientists think they are right.